It's about that time. Welcome, everyone. Good to see a couple of friends out here. Thanks for attending. This talk is called Bursting at the Seams. I'm sure you've all, I hope everyone's seen Tommy Boy. This is the one scene that I think about whenever I hear that expression, the fat guy in a little coat. As a kid, I would try and reproduce that. It's actually really hard to do that. So they must have pulled a couple threads out or something. I don't know. Anyways, this talk is about seams, what they are, why we care about them, how to work with them, and that's really the purpose of the talk. So a little overview. Oh, that's a Frisian horse, by the way. I have, very recently had a shaman tell me I needed more magic in my life and that I needed to have my spirit animals be a part of my daily life. And they gave me some spirit animals. So I threw some, I don't know, we'll see what happens. Here we are. So we're gonna look at some code. We'll talk about seams, what they are, why we care about them, and then we'll take a practical application of what we've learned and apply it to the code we just looked at. Really quickly, my name is David McDonald. That's another spirit animal that is jumping over me like the cow jumps over the moon, but that's an orca. I like orcas because they're matriarchal. I'm a software engineer at Weedmaps, so I'd like to thank Weedmaps for sponsoring me and allowing me to come out here and speak to you today. With that, let's dive into things. A quick note on the format. I generally like live coding talks. I know that they're treacherous and very difficult. Every time I've tried to do one, I bumble it, so I'm not going to be doing live coding today. Instead, this is going to be a talk where I have some screen grabs, and I talk at you about the screen grabs, and then I talk about previous screen grabs that we just looked at and compare them to new screen grabs. So, yeah. Sorry in advance if this is the pacing's too slow for you or if it's too quickly. I'm trying to thread a middle ground here so that everyone feels like they can kind of follow along. But patience is a virtue and a requirement for senior developers. With that, let's jump in. We have here a long-ish looking method called makeRequest. It takes 4 keyword arguments. 2 of them are required. It looks like a lot, but it's really just instantiating a couple of objects, and then executes those. Builds up some arguments for them. When we enter the method, we new up an instance of a signer. So we'll learn what that is here shortly. The signer instance takes a method and endpoint argument that we just passed in to makeRequest. And as you can see, we call that instance and we get back another object, something called a signed header. That itself we end up using to build up the arguments for yet another object that we'll get back from build request there in the middle. Next, we create an argument hash composed of the same method and endpoint args, and we also give them a meme and a body if that was passed in. So this is code you might have written yourself or seen before. It's a little bit hard to look at. It's a little long, right? Ultimately, we just issue a request here. You can probably see we're rescuing a REST client exception. So this is a REST client object here we're building at the end. So we finally issue that request, and we parse out the response, and we do something with that response. In this case, we're saving stuff locally in a database. This is just to give a little bit more context to what we're working with. You can see that large method we just went over is pretty much the bulk of this class here. We're going to call it a request class. There's another spirit animal. That's El Gato. That was given to me very recently. But I chose this example because it's not very complex. It's fairly readable, but it's really easy to nitpick stylistically. Any one of us in the room are probably going to pick out little things like, I don't like that you named it this way. I don't like that all the arguments are like this. I don't like that you have ivars that you're just directly calling inside this method. I don't like the name of that thing. So we could do that, or we could talk about what's really wrong with this method. And that's kind of the heart of this talk. Beyond talking about seams today, that's really what I want everyone in the room to kind of come away with. So let's just all kind of think to ourselves here or shout things out or whatever. What is wrong with this method? Some of you are probably saying a lot. Some of you might be saying, I don't know, not really a whole lot. Who even wrote this terrible thing? So yeah, I did write this method. I've changed some things up here just to obscure the source of this thing, but I wrote this a few years ago. I was going back and looking some source code, and that was kind of like the inspiration for this. Now, you could have listed a few things, like maybe listed off some solid principles, or Sandy would call them true principles. But the number one problem I see with this code is that it's just hard to change. There are a lot of places in the code base that are seemingly tied into this one method. It seems pretty crucial to the health of the application, and this speaks to what is probably the real point here. Software is meant to be changed. Otherwise, we'd probably implement it as hardware. If you're a software engineer, it is literally your job to change software. So the need to accommodate change in our code is one of the main reasons we write object-oriented code. I'd also add that code that is hard to test is often harder to change. It obviously depends on what the changes are, but if your code is really rigid or brittle, then it can just cause a lot of messes and a lot of time wasted, but I don't want to digress. What I wanted to focus on is how will this method, which seems really crucial to our application, respond to a change in requirements. So, to drive the point home, let's imagine a new requirement comes in. It's going to feel a little contrived here, but our users have recently been categorized into specific types of users. So each user has been given one of several levels, let's say gold or silver or bronze, and depending on which group or tier or level they're in, we have to sign each of these requests now with a different algorithm. So we're going to apply some kind of algorithm to each one of these requests. And this is a real thing that exists out there in the world, but in our cases, we're just going to pretend there's a time-locked service that we can only talk to during certain times of the day, and you have to have certain user permissions to do so, and you have to sign those requests each time, otherwise they won't be accepted. So we're really worried about security here. For now, there's only going to be two types of users. There's going to be a gold and a silver. Okay, but we know more will be forthcoming. So this is obviously going to require some changes to our code. There's the Orca again. We need to take a look back at our method. We know we need to add a new signer, or maybe that signer needs to apply a different algorithm depending on what our user is. So if it's a gold user or a silver user. So we need some kind of a way to toggle which one we're going to use, right? And we need to apply some logic to do that. But what does our signer even look like? Do we need to know? Do we need to worry about that? Take a quick look at it. Not really. It's not doing much special. There's some magic. That's where we're applying an algorithm, a hashing algorithm, okay? Do we really care? No. In fact, another developer in our team implemented that and is going to implement the future one and the one after that and the one after that. So we just know it's there. And we'll wave our hand and say another contributor implemented this entity called a channel, which delegates these calls off to a user and says, hey, are you a gold user or are you a silver user? Okay, so we have all this stuff ready. It's just up to us now to implement these new signer classes, we'll call them. Notice as well that we have these two instance methods here on the channel for a consumer ID and a private key. You might have noticed, we'll go back, that we use those here in our make request, okay? So that's where those are coming from. So let's quickly implement a naive approach to the problem. We need to create a new signer class or extend our current one. So for now, we'll just keep it really simple. We're just going to wrap our algorithm and repeat the code, copy paste. Two different signers, one's a gold one, one's a silver one, signer A, signer B, okay? So we basically cloned that whole class, yada yada. We wrote some unit tests. Those unit tests are passing. And now we're back to our make request method that we started with, where we can conditionally call one or the other. We already have a reference to the channel. So in our request class, we can go through and ask the channel, like, hey, is your user a gold user? Is your user a silver user? We can also just look up the consumer keys we went over, since those are instance methods on the channel, so we don't have to pass around raw instance variables, because that was bothering me, so we'll do that. We can also look up we can pass in our channel down into the request method, look up those consumer keys directly, ask other questions of this class because it's at our disposal. Our signer classes both have the same signatures, they take the same arguments, so we just build that up, check the channel level, and bing, bang, boom, we've implemented our new requirement there. We just ask the channel, hey, are you gold? If you are, call signer A, the gold signer, otherwise call the other one. Pretty simple, right? So is that really all we need to do? Have we really covered our bases here? Well, we run our tests, those are passing. We've been diligent and we've been thorough with our QA. We're ready to go, so we just ship this thing, right? What more could we do? Off the bat, you might be thinking, okay, well, didn't you say there's going to be more signers in the future? Yeah, I did say that, but those aren't here, right? We've only got 2, so should we worry about that now? As soon as we need to add another version of our signing algorithm, then we will be forced to make a change here. But is that really that big of a deal? We could turn this ternary operator here into a longer if-else statement or a case statement, right? But that means we are going to have to come in here and change this every time. And we don't know how many different signers are going to come through. Wouldn't it be nice if we could just affect change in this method without having to change the code ever? So let's just kind of pause there on that question. I'll freely admit that I've never had an original thought in my life. And I'm very dubious of anyone that claims that they have. I owe a lot to those who have come before me. One of those people is Michael Feathers, and specifically this great book, Working Effectively with Legacy Code. The whole premise for this talk comes from this book, Chapter 4 specifically. Please read it if you haven't. If you have, read it again. It's great stuff. Every single one of us has probably in this room worked in a legacy code base. He defines that as a code base that's not under test, meaning everything under test. We're probably all going to write code that is not under test at some point in the future. I know that I work on a couple of apps at Weedmaps that do have 100% code coverage and a couple others that don't. But very relevant for today, highly recommend it. It's from this book that we were first introduced to this concept called seams. So what are seams? We go back to that question we just discussed. Wouldn't it be nice if we could affect change in our request method from the outside without having to change the code itself? And this is really where seams comes into play. So a seam is a place that allows you to modify the behavior of whatever you're dealing with without modifying the code. That sounds pretty abstract without looking at something. Especially if you've never been introduced to this, you might be thinking actually of mocks or something like that off the top of your head if you're a Rubyist. You might be thinking of, okay, is this like dependency injection? Like what is this? So we'll get to a concrete example here with our code. The bigger question now is why we care about this. Michael Feathers in the book Working with Legacy Code is really focused on this idea of testability and getting something under test that is not yet under test. And having done that for years, he talks about this idea of seams emerging to him. To me, there's a lot more benefit to these things that we can really take advantage of just on a day-to-day basis. Once you start seeing your code and start noticing these seams, specifically what he calls object seams, refactorings and decoupling just kind of appear to you and it kind of comes naturally. So thinking about seams to me is all about thinking about dependencies. It's about finding and creating an incision point where we can loosen our dependencies. And this makes code easier to write tests for, which is a huge benefit, and that's really the benefit that he drives home well. But it also just makes it easier to change later. And like I said, our software is always changing. It's our job to change software. So let's make it easier on ourselves and for those after us, our future selves, but those coming down the line that are going to touch our code later, read our code later, write tests for our code later. In order to write effective tests, you need to break these dependencies. Thinking in terms of these themes will help you, first of all, identify dependencies. If working with dependencies is kind of a new concept to you, this is a great place to start. So this is kind of where I want to spend a little time. The analogy to me is like a seam in clothing. Here we have a seam on a baseball. If anyone's ever pitched or anything like that, you know how important seam placement is with your fingers and everything. But for me, I like the analogy of clothing. It's a place where two parts are stitched together. The piece on each side touches the other right at the seam. So back in software, if you identify a seam, you've identified a place where there's a well-defined interface, or an interface. That is where you can leverage something like dependency injection, meaning you can take one of these dependencies and stick it in there. You don't have to declare it directly in your code. I like that seams just get us talking about a lot of the solid principles, a lot of object-oriented principles in general. Like, it just is a nice way to talk about those things without having to talk about them directly. You know, maybe you don't really have a good common ground with somebody to talk about something like open-closed or something along those lines. This is an easy way to kind of get the ball rolling. Code complexity, extensibility, and testability have been hot topics in the industry since I've been around. Seams can help a novice to something like object-oriented programming really get up and running and help them think in terms that are really helpful and beneficial to the whole team. So hopefully those things can help make your code bases more flexible and more resilient to change. So let's take a look back at our implementation and ask this question: can a seam, so this thing that modifies the code without changing the code, modifies the behavior of the code without changing the code, can that help us here? We don't have a seam here, right? We got the little thinking emojis. Could we have a seam here? Looks like we could have done something right there, right? That seems like to be the hot spot in this method. But, you know, we've made our change, we deployed it, so game over, talk over, thanks for coming. Now the time is now, this is the talk, so a new requirement comes in. Now we have a bronze level. So this is a perfect time. We know what to do now. We know about seams. Oh yeah, that one spot where we put that ternary operator or that if statement, we need to go in there, create a seam. That'll make it easier for me to add the next signer that's inevitably coming down the line, right? So let's try and make use of that. Okay, we kind of have to get our bearings here, so let's take a look at the overall class. We have a new signer we want to slip in, but we just aren't set up for that yet. And to do this right, we kind of need to take a bigger picture of the overall application and how these signers are used, how this request class is used, right? So what are we dealing with? We have each of these signers, they take the same argument list. Is that possible? Looks like they do. We basically just want to pull those things out, let something else decide which one we need, and give that to our method, right? At that point, our method isn't the thing changing the behavior. It's whatever something else decided what that behavior is going to be. So let's go create a signer method that will just wrap up this logic here, and it will give us back the thing that we want. So we go ahead and do that. Down here at the bottom, we have our signer. It's going to forward along our method and our endpoint arguments that we got from before. If you look at the signer implementation above, it's really just copy paste from before. We've added signer C, which is our bronze signer. And bing, bang, boom, we're done, right? Our tests are passing. But what does this really give us? What have we gained here? Is our code more extensible? Is it easier to test? It is easier to test. Is it easier to read? Is it open, close? What happens next time we have to make a change and we had to add a fourth signer? Well, we just basically pushed the change off from our make request method into our new signer method. So I don't know, I'd argue that it's not really that great, but things start to emerge once you've made a change like this, right? So this doesn't fix everything, but this is the start of something. But what's the big deal with seams anyways? We just created a seam. That is a seam. You don't have to change the make request method to change the behavior of the make request method now. But believe it or not, this class, hey there, microphone. Believe it or not, this class is a lot more adaptable and easier to refactor. So once we create a seam like this, other improvements to the overall design tend to reveal themselves. Other places that know about this code show themselves as spots that can now be refactored and be a little bit more resilient. So seams, in addition to Michael Feather's insights about making your code bases easier to get under test, are like refactoring gateways. You've kind of opened up a whole new world to get your dependencies a little bit more breathing room and start to be able to move them around and say, does this class really want to be responsible for deciding which signer is to be applied on every request? Or is that the responsibility maybe of somebody else? So how far should we take this is now the next question. And from here we can go in a lot of directions actually. And the seam we've created has given us the flexibility to do that. And paired with our tests, we're able to make changes with this class without fear. So let's walk down the road I took just to kind of illustrate the point a little bit and some of the benefits that you can get. But really this is kind of up to you, right? It's how far do you need to change it? Do you expect more signers to come down the line? Is it really worth the time, effort trade-off? I argue that it almost always is, and hopefully I can kind of make that point here. So I basically pushed this one dependency out of my make request class and up a level. It's sitting there in the request itself, like we just kind of went over. Ideally, I'd like to do this. I'd like to just pass in a signer instance to my request class. I don't really want to worry about having to toggle things in this request class itself. I just want this request class to make requests. Build a request, make a request, parse the request. That's all I want it to do. I want someone else to have to worry about that other stuff. So this is what I want, ideally, to end up with. For that to work, I have to zoom out a little bit and rethink things. So let's briefly look at the request class and how it's used. You have here at the bottom there on the left a RefreshStats Worker that I've made up. It is going to take an ID of a channel. It looks up that channel. It creates an instance of the request class that is memoized. The request class passes in a channel so that we can get things like the consumer ID and the private key and what level, what tier our channel or our user is in. And then we're going to call methods like RefreshStats on that request instance. RefreshStats is going to forward along dynamic pieces of information we need, like what kind of HTTP method it is, what the actual endpoint is, and then we're back to our familiar make request method. So that's what we're dealing with here. So it looks like we can actually pull this off. The channel already knows about the levels, right? Gold, silver, and bronze. It already knows about our credentials. And we only really were using those to pass them along to the signer. So if we'd like to avoid toggling which signer gets used in the request class, we don't just have to let channel pick the signer, we can pass it in with itself to request. If we examine what changes in signer, what changes in signer are dynamic and which ones are static. We just saw that RefreshStats passes in a couple of dynamic pieces, but the consumer ID and the private key, those are never going to change. So let's kind of really quickly rework our signer. We want them to kind of look like this. Just pass them a consumer ID and a private key. We'll get an instance of a signer back. And then every time we need to call a signer request, we can just pass in the dynamic pieces it needs and move on. There's a Frisian horse again for you all. And you wouldn't even need to keep injecting your channel into the request this way. The only reason we were doing that is so we could forward them along to the signer anyways. Now we just do all that inside of channel. So I basically just moved that logic out into the channel, from the request into channel. When we new up a request, instead of passing in the channel itself into the request, we'll just pass along the signer. I know this might be moving along a little quickly at this point, but so you may or may not be losing track of like where we're at here. But that's okay because we're essentially done here. I really just wanted to push this out there and show you like, look, this is how you can start thinking, all because I started to make one seam. We had no seam, we created a seam, and these dependencies kind of automatically drifted apart, and we thought, okay, well, I could actually move this out, make this class a little cleaner, make this class have this certain responsibility, and certain design flaws started to reveal themselves without me even having to think about it. So you kind of have to stop where you feel best. There's a trade-off here that we always have to make when software is changing. I took it even further, and I thought, whose responsibility is it to determine which signing algorithm to use? We accomplished our job already, but I thought, okay, well, a signer is just really applying certain algorithms. This is a perfect instance for polymorphism. We can just have a signer be responsible for newing up these credentials, and then based on what channel, whether it's a gold or a silver or a bronze or whatever, we can just have a different application of the algorithm applied. And you can kind of see how I ended up here. You could keep going. And that's really the point here, is that I've now been allowed to have the space to do this refactoring, make things a little bit more readable, have less code overall, which is always, not always a win, but to me it's generally a win. In Ruby you can do a lot of fun stuff with string interpolation and constantizing things that can get you in a lot of trouble. So I tried to avoid that here. Sometimes it's a useful tool to reach for. Ultimately, I just split out all the algos on their own, and that's just the point. You can kind of go as far as you want with this. So I just would like to end on this note that Michael Feathers really focused on his work over the years of getting code bases that were not under test. And from that work, the concept of seams comes to us. So it's, again, the ability to change the behavior of a method or an object without having to change the code itself. And this idea kind of emerged. He really underlines how powerful this tool can be to reach for, but he kind of focuses exclusively on the tests. And as you've noticed here, I'm mentioning that I've got tests, but I haven't shown you any tests. We haven't written any tests, because that's not really the point here. The point here is that I've noticed in my work, as I begin to see my code base, the things I work on in terms of seams, that refactoring reveals itself. Decoupling happens naturally. When I say, it'd be nice if I could change the behavior of this class or this method, I'm automatically thinking of seams. So hopefully that is a benefit that you're all starting to notice for yourselves as well. I've noticed it's a topic that's not really brought up that often, and it's a very useful one. So my goal is really to reintroduce that concept today, to how you can start to identify places in your code to make that crucial incision, that first spot, and how you can have your code base burst at the seams and get more fruitful refactorings when those requirements inevitably come in. So with that, there's my Twitter handle there if you want to follow me on Twitter. Yeah, thank you. With that, I can take a couple of questions. We have a few minutes. Ooh, put me on the spot. So Shane asked if I'd mentioned solid principles and also true principles, and I attributed the true principles to Sandy Metz, who just spoke earlier. I believe she mentioned them in her practical object-oriented design with the Ruby book. I got a thumbs up in the back there, thank you, sir. But she's written a lot of books, all of which I have read and I recommend to you. It's basically a pared down version specific to Ruby of the solid principles. So there's 4 instead of 5. Yeah.
Do you remember what they stand for?
No, but I could gaggle it. Google? I could Google it. You all have Google. Okay, thanks everybody.